normal approximation to the binomial distribution. If you think back, binomial distributions were when you had two outcomes and that was all. Or if you could think of a situation or event as just two outcomes. Now we're going to incorporate that with the normal approximation or normal distributions. So when you have to do this, it's going to be when you have an event happen, a probability of an event happening which has or could be thought of as just two outcomes. And you'll also notice that you will not be told the mean or the standard deviation, which is something of which you have been told in the past. Now, you are going to have to set these up using the proper notation to begin with. As you'll see on the left side here, probability x equals a, probability x greater than or equal to something, probability x greater than something, and so on. And it says, if you have these, you're going to immediately need to first change that into one of these, where the inequality is not changed in direction, well, except for the equals. That's going to be between two values. But for all the others, you're going to either be adding a half or subtracting a half from the value you're trying to find the probability of. Now, for all of these, the mean is equal to n times p. Think back to the binomial distributions. P represented the probability of something happening. And then standard deviation, I know it says square root of npq, but you can also think of this, and I believe I may have mentioned it in the other video with binomial distributions. Standard deviation can be thought of as just taking your mean times q, square rooting it, which is generally what I'm going to be doing here. Okay, so first here it says of all 3 to 5-year-old children, 56% are enrolled in school. If a sample of 500 such children is randomly selected, find the probability that at least 250 will be enrolled in school. So how do I know this falls within the normal approximation to the binomial distribution? Nowhere here does it talk about a mean or standard deviation, but it does give you a probability of like your sample, which is the 56%, or you'll be thinking of that as 0.56. Now, you can take 2 points of view here. And sometimes when you're reading this, you're going to have to make sure everything's talking about the same perspective. Like here, we are talking about children enrolled in school. Now, somewhere here, maybe they said this many percent is not enrolled, but how many are enrolled? Well, then you're going to have to make sure to figure out, okay, 1 minus what it gives me will give me actually what I'm looking for, which is what I'm going to work with. Now here, let's set this up. So once you find the probability that at least 250 are enrolled in school, so x would be greater than or equal to 250. And yeah, it makes a difference whether you have greater than or greater than equal to here, because that's going to be two separate things you would do to 250. So this we'll immediately need to look at to figure out how to change it. So at least, which is greater than or equal, says you're going to change that to just greater than, but subtract a half from the value you are given. So this will become the probability that x is greater than 249.5. And then yes, we are then going to change that into the probability that is z is greater than something. Now, we need to figure out the value of mu and standard deviation so we can use the z-score formula. So here, mu equals n times p. Well, I know my total number amount said sample 500, so that's 500. Now, P is the probability of this thing happening. This is talking about enrolled in school, so the probability of being enrolled in school is 56%, so 0.56 would represent P. Now, that also gives you Q. You take 1 minus this, and that will give you the value of it not happening, which in this case would be 0.44. So take this times 0.56 and plug this into a calculator, and you should get 280. Okay. Now we need to find the standard deviation. So for the standard deviation of this thing, we are going to need to take our mean times Q and then square root it. Now generally what you would have just done is you would have just done 0.56 times 500, there you go, 280. Now what you're going to need to do is you're going to need to take the square root of that 280 times, in this case 0.44, and you're going to leave that in your calculator. So it looks like this gives us about 11.099. Or actually it'd be, because this is going to have to round it up, so 11.0995 I'll say. I'll just leave it at that. For what we write down, it's okay. It's not going to matter. So we took 280 times 0.44, square rooted it, and 11.0995. It's okay to write it down like this. That's no biggie, because now what we're going to do is we're going to use a z-score formula. Now, yes, you have two different formulas. You have one for probability of means, which is central limit theorem, and probability of not means, which is this case, which is just taking your x minus your mu, dividing that by standard deviation. So you'll have 249.5. Yes, you use this value. Once you change it, you never go back to what it was. Minus your mu, divided by standard deviation, and don't you dare punch this in. 11.0995, that is. You can always write down rounded numbers, but never use rounded numbers, ever. So what we have is we have this fraction, which is 249.5 minus 280, and it's all on top of, what do you do to get this? And by the way, there are decimals beyond this 4 that it is not showing. There will always be more decimals beyond what your calculator shows, especially if you got something weird like this. So you just use the answer key, and that gives you the exact result. Always use that answer key. Always go back and just change values in a formula if you can. So this would be negative 2.75, because this is a z-score, and z-scores are always rounded to the second decimal. So we have z equaling negative 2.75. Go back up to the top, fill it in. So negative 2.75, and now we can work with the picture on this. I forgot to put pictures in this before I started it, but that's okay. So here's the negative 2.75, and that's what I need to look up on the table. So we're going to 2.7. This is for 0, 1, 2, 3, 4, 5, so 0.497. Now what did it ask for? Did it ask for greater than the z or less than? It asked for greater than that z. So it is wanting all of this. Well, all of this is a half, so you would just need to add these two. That's easy to do even without showing work, because you're just going to get 0.5 plus this, so 0.997 would be your end result here. Okay. So here, it says a company has an 8% failure rate with shipments. If the company ships to 600 people, find the probability of getting fewer than 40 issues with shipments. Now this one here, I'm going to make an Easter egg. So the homework, which would cover this, just make sure to add that one on there. So now it says the rate of U.S. home ownership was 65.9%. Choose a random sample of 120 households across the U.S. What's the probability that 65 to 85 inclusive of them live in homes that they own? So there's a lot said going on here. First I need to write this probability it's asking for symbolically. So it's the probability of 65 to 85, but it says inclusive. Inclusive means you're going to include 65 and you're going to include 85. And what you're wanting is between them. So that's how you would write this. Now you have two inequalities here. This is a conjunction. That's what conjunctions are. The two inequalities combined to be one. Now you're going to have to identify which is which. And do you add a half, subtract a half to 65, or 85? Okay. So for this one, I have 65 smaller or equal to something. But this is backwards, or it's backwards. So I had 65 smaller than or equal to something. Well, this has the inequality pointing at the number. Well, fine then. Switch sides, but make sure you're pointing at the number. These are equivalent. It's a way to rewrite an inequality. So that means what I'm going to have to do is I'm going to need to subtract half from this. So this would become 64 and a half. Now the other one I can take as it is, just this piece right there. And for that, what I'm going to need to do is add a half. Look back at the table, you'll find it matches. So now I'll need to find or change both of these into z-scores. So be it. That's fine. But this will become probability of some z-score stuck between two numbers. So first, I need my mu. And then that will help me figure out standard deviation. So mu is equal to n times p. We're talking about how many people or things in total. What's your sample? That's 120. Now this is wanting that live in homes. So is there a probability of living in homes somewhere? That they own, that is. Yes. It's this, which you can change into a decimal as 0.659. Might as well get Q out of that. 1 minus this guy is going to give you 0.341. So here, 0.659, plug it in, and it's going to give you 79.08. Then for mu on this is going to be square root of 79.08 multiplied with 0.341. And this will end up being 5.19, and it keeps going and going and going. You can write it down, but don't clear it out of your calculator, because now we need to use that in order to change both of these to z-scores. So we'll have 64.5 to begin, minus 79.08, all on top of 5.19. And this is going to come out to approximately negative 2.81. Change 64.5 to 85.5. So if you're punching this in a calculator, literally that's what I do. I'd recall this as it was. Now you have to be careful if you use the answer key though. And I'll show you what that process would look like. So what we did was we had to do the square root 79.08 times 0.341 gives us that, and then what you probably already punched in was this, 64.5 minus 79.08, close it, divided by my answer. There it is. You probably pushed enter, but what you're going to have to do is you're going to have to go back to getting this. So I'm going to need to recall this thing. So however you would recall that and push enter, that's what you would need. So square root 79.08 times 0.341, and then again 60, in this case 85.5 minus 79.08, close, divided by my answer, looks like 1.24. So 1.24 here. So I'm going to need to look up both of those and draw a picture. So here's my picture. 0. Positive, negative z-scores. Negative 2.81. And my positive was 124. And I'll need to look up both. Look up this one. It's going to give you 0.4975. Look up this one. It's going to give you 0.3925. And what it wants is what was between these. So from here all the way on to there. So 0.4975 plus this, and you should end up with just flat 0.49 or 4900. Okay. So college students often make up a substantial portion of the population of college cities and towns. Champaign, Illinois ranks with 71.1% of its population made up of college students. What's the probability that in a random sample of 150 people from Champaign, more than 50 are not college students? So let's start building this. We need the probability. What's the probability that more than 50 are not college students? So more than 50 and not college students. Well, the greater than, go way back to the top. Strictly greater than says add a half. Okay, so we'll add a half. So this will become probability of x greater than 50.5. Wanted to make it a capital P. Just do that for now. So, we're going to need, this will become a z-score, still greater than. We're going to need to figure out P and Q. Okay? So it says 71.1%. But that's referring to the college students. This is saying not college students. So here it actually gives you Q as 0.711. And you're to figure out the lowercase p. The lowercase p in this is going to be 0.289. So mu would equal the number of your sample, which was 150, times 0.289, and you should end up with 43.35. Standard deviation would be that exact result times the other, in this case Q, square root it, and this will end up becoming approximately 5.55. Okay, so now we can actually do the z-score. So 50.5 minus the mean, this is going to be a positive z-score, divided by my answer. Never punch it in, use the answer key. And you should end up with z becoming 1.29. Okay, so now picture. So 1.29 would be over here. Look up 1.29 on the z-score table, and you should get 0.4015. And what this wanted is it wanted greater than. So it's wanting this part, which means I'm going to have to take a half minus what I have, so it would be 0.0985. And that's it as far as examples I have for this lesson. Yeah, it's pretty repetitive, but I wanted to give you an insight of when it might tell you the probability that you're not essentially wanting, but how you can use that to get the probability you need. And also, if you want it to be between two values, you've given a conjunction, how to still make this work with conjunctions. See you in the next one.